In this video, we are going to be looking at hexadecimals. So we're going to be able to explain the use of hexadecimal numbers to represent binary numbers. We're going to be able to convert positive denary whole numbers from 0 to 255 into two-digit hexadecimal numbers and vice versa. And we're going to be able to convert between binary and hexadecimal equivalents of the same number. So a few key words: hexadecimal, binary, denary, and base 16. So in order to watch this video, you need to have some knowledge of the binary number system, and I'll be looking at that in another video as well, but you should be able to follow this one. So listen close and hopefully we can learn something. So base number, a base number. So if denary is base 10 number system, if denary is a base 10 number system, then what number system is binary? So when we talk about base 10, we're talking about that little number at the bottom. Base 10. So binary is a base 2 number system because in denary we can go from 0 to 9, which is actually 10 numbers, and in binary we can only go as high as 1. So 0 and 1, that's 2 numbers, making this a base 2 number system. And if you remember how to do your conversions, these are 8 bits, which make up a byte, and if it's 1, it means it's on. So we count 128 plus 16 plus 4 and plus 2. So hexadecimal, or hex for short, hexadecimal or hex for short, is a number system which uses base 16. Base 16. So as we only have 10 digits, it uses 0 to 9 and then it uses the letters A to F. Because when you get into the base 10 number system, 10 is actually 2 digits. 10 is 2 digits, which remember we split into units. And then we've got tens, or 10 to the power 1. So this is our denary number system, where we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's actually 16 numbers there, just to confuse you a little bit. There's 16 numbers there because we count 0 as a number. And in hexadecimal, we start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then when we want to say 10, we actually say A. And for 11, we say B, 12, C, 13, D, 14, E, and 15, F. So what is denary 10 in hex? Well, denary 10 in hex would be A. And what is hex E in denary? Well, we go to a little table and we can look at E, and that would be 14. Now, what's great about this is that it's only 15. It only goes up to 15. So we only need to remember 1, 2, 3, 4, 5, 6 letters. We only need to remember 6 letters. So, and whenever you write an exam question that asks you to convert from denary to hexadecimal, I always recommend writing this table out so you always know. And so when you have something as simple as this to do, you can answer it really quickly. So, hex to denary conversion. You'll only need to translate 1 or 2-digit hexadecimal numbers. That means 2A hex, that's a 2-digit hexadecimal number. It's a 2-digit hexadecimal number. That's 1 digit, that's 2 digits, okay? If we had to do 3 digits, which we don't, that would be 16 to the power 2. So when we calculate this, we multiply the left-hand digit by 16, because 16 to the power 1 is 16. So we're doing 2 times 16. And we add the units on the left, on the right. We add the units on the right, because 16 to the power 0 is 1. So A is 10. So 2 times 16 gives you 34. Did I make a mistake there? Yes. 2 times 16 equals 32. 2 times 16 equals 32. Just checking if you're listening. Plus A, which equals 10. So we need to convert that back to denary, because A equals 10, which gives me 42 in denary. So before I move on, try and do the following calculation. What would 2,7 hex be in Denary? 2,7 hex be. So you need to do 2 times 16, because that's in the left column, plus 7. So you should have gotten 32, if your maths is better than mine, plus 7, which will give you 39. It should give you 39, and it's really important that you specify that it's 39 denary, just so that no one confuses it. So if you want to pause, you can take a look at this page just to re-familiarize yourself with the process. Now, when we want to convert backwards, we want to convert from denary to hexadecimal. We want to convert from denary to hexadecimal. So we have to divide the denary number by 16 to get the number of 16s, i.e. what's on the left-hand side. And then the remainder gives you the units. So when I divide denary 18, when I divide it by 16, 16 goes into 18 once. Don't worry about getting your calculators out, which you're not allowed in your Component 2 exam. 16 goes into 18 once, and the remainder of that is 2. So the hex value for 18 is 1, 2. So be really careful. It's not 12, it's 1, 2. That's how we speak in hex. It's 1, 2. And if we actually reverse that, if I go 1, 2, and we put our table back here like we had before, so 16 to the power 1, 16 to the power 0, so that would be 1 times 16, which equals 16, plus 2, which gives me 18. So we can do it from hexadecimal to denary, and then we can do it from denary to hexadecimal. So try the following out. What is denary 27 in hex, and what is denary 44 in hex? If you want to pause the video. So here's a couple of practice questions. And I recommend that you pause the video here. And now I'm going to move on to the answers. So denary 19 in hexadecimal would be 16 goes into 19 once with a remainder of 3. So the hexadecimal is 1, 3. Denary 44, well, 16 goes into 44 twice. 16 goes into 44 twice with the remainder of C. So if we remember our table, A was 10, B was 11, and C was 12. So 2 remained to 12, and we convert that 12 into C. And then if we go the other way around, hexadecimal 1, 9 equals denary 25, which would be 1 times 16 plus 9, which equals 25. And hexadecimal A3 equals denary 163. So A, which is 10 times 16, is 160, plus 3 gives you 163. And if you attempted the stretch, you've got denary 256 is equal to hexadecimal 100, which actually shows you that the maximum number that we can represent with 2 hexadecimal digits is 255, which you might recognize as being the same number that we can represent using 8 bits or 1 byte. And finally, if we had 3 hexadecimals, so we had FFF, that would translate to the number 4095. So convert binary to hex by splitting it into nibbles. Now, if we want to convert from binary to hexadecimal, and that's what we're looking at, you need to split the two. You need to split the 2 nibbles. So 4 bits is a nibble, 4 bits is a nibble. 2 nibbles make a byte. So take the binary word of 8 bits and split it in 2. And then you convert each nibble into its denary then hex value. Now, if you remember when we do binary conversion, let's draw our table here. So that would actually be 1, that would have a 2 on top of it, that would have a 4 on top of it, and that would have an 8. Now we're not going to continue to 16 because we split it, so this is going to be 1, 2, 4, and 8. Okay? Now when we convert these two numbers, I'm going to do 8 plus 4, which is 12, plus 2 gives me 14. And if I convert these numbers, I've got 4 plus 1, which is 5. So that's the denary value. So when I convert each nibble into its denary and then hex, I just rejoin them. So 1110 was 14, which is E in hex, and 0101 is 5, which is 5 in hex. And when I join the two back together, it gives me 1110, 0101, which is E5 in hexadecimal. Now, if you want to double check that this was correct, then go ahead and convert it back into denary. And you might find that this way actually takes a little bit longer than converting it from binary. So E, you would do times 16, so 14 times 16 plus 5. Or you can do it this way around, and now that we've rejoined these numbers, we've got 1, 2, 4, 8, 16, 32, 64, and then finally 128. And if we add all the on bits up, we end up with, what do we end up with? I'll let you work that one out. So the last thing that we're going to look at is going the other way around. So can we work from hexadecimal to binary? So we're going to use the same method. We're going to split our hexadecimal up into two. We're going to split our hexadecimal up into two characters. And we know that 3 in hexadecimal is 3 in denary, which would work out to 0011, which would work out to 0011 in binary. And B is 11, which would work out to 1011, 1011, because we've got 8 plus 2 plus 1. And now that I've converted my two nibbles, I join them back together, and I get 3b equals 0011, 1011. Now, what I would say is try and convert that into denary, just because it's good practice, and it's a great way of double checking your conversions are correct. So that would be 32, and that would be 64, and then finally 128. Okay, so as a little bit of a practice, what is hex 21 in binary? Remember to split them. What is hex A5 in binary? And here are some practice exercises that I'll leave you with, and you can pause your video here and try them out. And now I'm going to move over to the answers. So I'm not going to run through all the answers here. If you are not too sure on the method or how I got these answers, then what I recommend is you rewind the video and try and take a look again and go through the examples with me. And what's really important is that you show you're working out. So this has been hexadecimals, converting denary to hex, hex to denary, converting binary to hex, and hex to binary. I hope you found this useful. Thanks for listening. Bye.